Hello, ladies and gentlemen. This is Mrs. Stanis here presenting to you Saxon Lesson 84, which is Order of Operations Part 2. Now, we have had an Order of Operations lesson in the past. This is adding to that. It's a review and then adding a little bit of information to it. So please have your notes in front of you and a pencil, and we will start by reading what's up top here that says, recall that the four operations of arithmetic are addition, subtraction, multiplication, and division. Of course, those are the building blocks of everything we do in math, along with numbers. So when more than one type of operation occurs in the same expression, we perform the operations in the order described below. So in this little box, we have some rules, how to get the right answer, basically, and how to simplify expressions or solve equations. So order of operations, it says, number one, perform operations within parentheses. So anything inside parentheses, no matter what it is, has to get solved or simplified first. You might remember PEMDAS, or please excuse my dear Aunt Sally. The P stands for parentheses, because it's like the king. There's your parentheses. It's the king. You do that one first, or the queen. Okay, the second thing is actually exponents, but that's not part of this lesson. There will be a third order of operations lesson later on. So if there's any exponents, you would simplify those next. After that, we have what's down here. It skipped exponents, like I said, in this lesson, but you would multiply and divide from left to right. That's the order that we do things. That's the order that we write, the order that we read. That's how you solve math equations and simplify expressions. So multiply and divide are equals. I'm going to put a double underline because they're equals. So you can divide before you multiply. You just do whichever one comes first from left to right. Then adding and subtracting, it's the same story. Add and subtract from left to right. Adding and subtracting are equals, hence the equal sign is my underline. You can subtract before you add. That is okay. They're on the same level. Okay, so again, it's from left to right. All right, so let's put this into practice here and simplify example 1. This is an expression because there's no equal sign. If there was an equal sign, it would be called an equation. And good job if you thought of that before I said it. So we have 2 times 8 plus 2 times 6. There's no parentheses. I'm just going to rewrite PEMDAS here to help me go through. No parentheses, no exponents. So I'm going to multiply and divide first. So I would do 2 times 8, skip over the adding, do 2 times 6, and then add them. So 2 times 8 is 16. 2 times 6 is 12. When I add them up, I get 28. And that is the answer when I simplify that expression. Remember that calculators actually at Volano School, they're designed to recognize standard order of operations. They are, quote, algebraic logic calculators, which in other words means that they're smart calculators. They recognize order of operations. So if you plug 2 times 8 plus 2 times 6 into a calculator at Volano School, or one of the 6th grade ones, you will get 28. It says not all calculators will do this, though. So be careful if you're using one from home. Some of the old calculators or really cheap ones that are just designed to do the 4 operations, they might not recognize order of operations and you might get the wrong answer. It might do, and I'm just going to label this as the wrong answer or the wrong way, would be to do 2 times 8, get 16, then to add the 2 and get 18. So 16 plus 2 is 18. And then to do 18 times 6. That would be wrong. And I don't even know what it would be, but it's some wrong answer. So don't do it that way. If you have a calculator that is does not recognize order of operations, you will get whatever 18 times 6 equals, which I think is 108. Yeah, I think so. I'm just doing it in my head. Okay, so here's another problem-solving opportunity using order of operations. As with all the lessons, feel free to pause and try things on your own and then come back and check in. So it says, in Mr. Jackson's store, 3 shelves display hats for sale. 5 of the 7 hats on each shelf have been sold. How many hats have not been sold? Now there's 2 expressions here, and it says, equations, because there's equal signs. And it says, which equation represents the information in the problem? How do you know? Okay, so let me reread it. In Mr. Jackson's store, 3 shelves display hats for sale. So I'm just literally picturing 3 shelves. 5 of the 7 hats on each shelf have been sold. So that means that there were originally 7 hats on each shelf. 1, 2, 3, 4, 5. I'm just drawing this for the visual learners. Very small, but nonetheless, I am drawing it. So 5 of the 7 hats on each shelf have been sold. So that means, like, I'm going to just shade out the ones that have been sold. 4, 5. 1, 2, 3, 4, 5. On each shelf, it says. So that means 15 hats really have been sold. How many hats have not been sold? Okay, so it looks like 2, 4, 6 would be the answer. So n would equal 6 in these equations, but we have to find the right one. So how do I know? Let's see. Well, I know that there are 7 hats on each shelf, so that's 21 hats total, 3 times 7. And that's actually in both equations. So it's the second part that's going to determine our right answer. Now this one, the top one, subtracts 3 times 5 because there were 5 hats on 3 shelves and 5 hats on each shelf have been sold. So that one seems like the right answer because there were 5, 5, and 5. That's 15 that were sold. In this bottom equation, it's only subtracting 5, indicating that just 5 hats in total have been sold, and that's not true. It says 5 of 7 hats on each shelf were sold. So the second equation is definitely, after thinking it through, the wrong answer. The correct equation to represent this problem is the first one, because we have 21 hats, 15 were sold, and that leaves 6. And that's the answer that we determined with the picture and through thinking it over. Here we would just have 21 minus 5, which is not 6, it's 16. And that's not how many hats were left. So that's how we know. Okay, example 2. So remembering PEMDAS, we are going to see if we have any parentheses. No exponents. So that leaves me with multiplying and dividing. So I know I'm going to do 5/10 divided by 5/10 first, and then 5/10 times 5/10 after that, and then I'll add and subtract. So I'm just going to recopy this first number here, 5/10 plus, well, I don't have to do any fancy subtraction because anything divided by itself equals 1, so I know that. And then I'll put my subtraction sign, and 5/10 times 5/10, well, I know 5 times 5 is 25, and there's 2 decimal places, so 1, 2, 0.25. Okay, now I will add and subtract from left to right. Let me just put the arrows here so you can see where each number came from. So 1 plus 5/10 is 1.5, or 1 5/10. Now I can subtract the 25/100ths, and I can think of it like money. If I add a 0 here, $1.50 minus 25 cents is $1.25. But in this case, it's not money. It's just 1 25/100ths. And that's our simplified answer. Okay, example 3. Simplify 2 times the quantity 8 plus 6. This time we have parentheses. So we are going to do that first. The 8 plus 6 is 14. Now we can do 2 times 14. No exponents, obviously. So we can multiply and divide. And that's 2 times 14, which is 28. Now you might notice example 3 has the same answer as example 1, 28. That's because example 1 and example 3 are related. It's really the same problem. And I want to just remind you of something called, and you can add this to your notes please, distributive property. We learned it earlier in the year in an extension. Oops, I was going to write extension instead of property. Distributive property. The distributive property tells us, and I'm just going to recopy the expression. If we have a number that's being multiplied by a sum that's in parentheses, you can take the 2 and distribute it across the sum. 2 times 8, and then do 2 times 6, and then add them up. And you will get the same thing as if you had used order of operations. So looking at that, it's the same thing as example 1. 2 times 8 is 16. 2 times 6 is 12. Then we add them, and you get 28. And notice it's the same thing we got with order of operations. So that's called the distributive property. Why don't you try another one really quickly for me? See if you can solve 3 times the quantity of 2 plus 7 using distributive property and order of operations. See what you get, and we will talk about it in class. Okay. And that brings us to the practice set. So once you're done with finishing up example 3 there, work on the practice set, remembering order of operations, and that's all for now. We'll go over them in class. So thank you and see you next time.